Amazon DynamoDB is a fully managed NoSQL database which provides fast and predictable performance with seamless scalability. With DynamoDB, you can create database tables that can store and retrieve any amounts of data and serve any level of request traffic. DynamoDB supports on-demand backup, point-in-time recovery of data, automatic expiry of items, and many other features. DynamoDB is a fully managed database, which means you don't have to spin up any servers, install softwares, and maintain the upgrades of them. This is all done for us by Amazon Web Services, also called as AWS. In this video, let's learn more about DynamoDB, the core components, and how it can work from a .NET-based application. We will learn how to make create, read, update, and delete operations from a .NET application, how to connect to a DynamoDB, and also use the SDK that comes by default. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos around cloud, DevOps, and .NET. I'm sure one of this interests you, so make sure to hit the subscribe button to help me grow this channel. Without much delay, let's go to the command line and create a new API application that we will use for this video. So I'll use the .NET CLI and specify the new command and the Web API template. This will create a new ASP.NET Web API application in this current directory. I'll open this up in Rider IDE. To do that, I'll specify Rider64 and specify dot to open the current folder. I have the API application opened up. So we have the program.cs, the startup.cs, as in any ASP.NET Web API application, and we have a default controller, which is the weather forecast controller. Now this currently creates some dummy data inside this and returns on the get call. Let's run this application to make sure it is working fine. The application is running, so it launches the Swagger endpoint, which is set up by default for this API application. So we can go to the weather forecast endpoint, use try it out, and click the execute button. Now this returns back the hard-coded data that we saw in the controller endpoint. Now let's move this data into a DynamoDB database and see how we can access it from there. We will also see how to add items to it and then update and delete them as well. Let's switch over to the AWS Management Console, which I have already opened, and we can go to DynamoDB. Since I had recently visited this service, it comes up under here. If not, you can search for DynamoDB in this top search bar, and this opens up DynamoDB. In AWS, DynamoDB is not an instance-based application. You cannot create an instance for each of your application. This DynamoDB service is unique for this particular region and your account. So inside here, I can start creating tables. Now I have the region selected as Sydney, which is AP Southeast 2, which we will be using in a short while. The core components in DynamoDB are tables, items, and attributes. A table is a collection of items, and each item is a collection of attributes. Let's explore each of these terms in detail. To start creating a table, you can either click the Create Table button here or expand the menu on this left and go to Tables and create a table from here as well. So let's click Create Table. To create a table, we need the table name. Switching back to our application in Rider, we have this API returning a list of weather forecast. So let's navigate to weather forecast and we can see different properties inside here, which is the JSON data that gets returned for this API. So we'll create a table that matches exactly the name of this type. This is purely for conventional purposes, and I'll show you how you can override this name if you want to. So let's copy this, navigate back to AWS and specify the table name as weather forecast. Next, it asks for a primary key, which is a partition key. So before we provide that, let's understand a bit more about primary keys in DynamoDB. DynamoDB supports two kinds of primary keys. One, which is simply a partition key, in which case it is composed of just one attribute. In case when a table has only one attribute primary key, these values needs to be unique, which means no two items can have the same partition key value. It also supports partition key and sort key. In this case, this is referred to as composite primary key. So this has two attributes. In these cases, DynamoDB uses the partition key to create a hash value. The hash value determines the partition that the item needs to be stored. Within the partition, these values are sorted based on the sort key. Now the combination of these two attributes must be unique for any item. So you can have items that have the same partition key or the same range key, but both of them together must be unique. If we head back to our API application, we can see that the weather forecast has a date and it specifies the temperature and a summary. Normally, the weather forecast is for a place or a city, which is missing in this particular data object. So let's add in a new property, which is a string, and specify the name as city. So this will represent the city for which this weather data is applicable. Now, if we navigate back to the weather forecast controller, we can get in a city because you always want to get the weather forecast for a particular city. So let's take in the city name as part of the controller. To make it working by default, let's keep a default city name. I'll keep it Brisbane for now. Let's hardcode this city when we return back the data. So let's specify city, the same as the parameter that comes into the web API. So this works as expected, and this is going to return a list of weather data like before. Now in this case, a weather data is created for a particular date and a particular city. So the combination of the city and the date is always going to be unique. Now in this particular case, I need the data based on city names. So we can keep the city as to be the partition key. So the data will be partitioned across the city names. Now within each city name, for a date, this is going to be unique. So we can keep the sort key as the date. So a combination of these two will be unique. So let's head back to the console and continue creating this table. So here, for the partition key, let's keep it city. Note, this is case sensitive. So since my properties start with a capital letter, I am naming it accordingly. Now I also need a sort key. So let's click this checkbox. Now if you were to specify just city, then that's the case where it only has the partition key. So let's specify that sort key and give it date, which is the property that is there inside the weather forecast as date. By default, it uses the default settings, which you can override by clicking here. You can select the read-write capacity mode, which is basically determining the pricing of this table. If you click the link here, it takes you to the pricing and shows the difference between the two modes. Now, for the on-demand capacity, this is usually used with unknown workloads, and the provisioned capacity mode is usually used when there is a high predictable set of traffic. Now, navigating back, you can see I am running on a free tier, so I am only eligible for provisioned. Now, I don't want to get charged extra for this, so I will leave it like that. Now, with provisioned, you can also specify the read and write capacity, which you can learn more about in the capacity calculator. So let's skip this advanced settings for now, scroll up and use the default settings. Let's click create, and this is going to create a new table for us inside Amazon DynamoDB under this Sydney region. So you can see here, we have a weather forecast table created. If I switch over to a different region, let's say if I go to Singapore, this table does not exist there. I'll have to create a completely new one. Now switching back to my original region, which is Sydney for now. Clicking on the table name navigates onto the table details, and you can start creating items inside of this. You can see the high level details of this table right over here. So this specifies the primary key, sort key, and the other details associated with this table. To create items, you can navigate off to the items tab and start creating items here. To create one, you can click the create item, and this pops up a nice little dialog to add. So this by default has the city and the date defined. This is because this is our primary key. So any item added to this particular table needs these two properties. It can have any other attributes, but mandatorily have these two. To enter the data in a JSON format, you can click the tree and select text. Now this is pure JSON format, but this still needs these two properties. Let me paste in a new item. So I have the city, the date, the summary, and the temperature, which are the same properties that was there in our weather forecast class in C#. So this adds a new item to this database. So let's click save. If you want to add more items, you can again click create item and also specify the values inside this editor. Now I prefer this text mode, so let's select that and replace it again with new values. Now in this case, I have the city name as the same, which is Brisbane. However, the date values are changing. So I have 2021 4 of 5, which is April 5th, that's today. And also I have the data for 6th. Now this time component is also making it unique. So I could have values which is having a different time, but for the same date. But let's stick to one value for a date in this particular scenario. Now here we have tables which has items and which has attributes inside them. Two of these attributes constitute the primary key, which is a composite key. And there are other attributes. Now if we try to create a new item, let's select test again and create a value for the 7th of April. And if I remove the city name and try to save it, it says it cannot process this request because that is mandatory. So let's add that value back in and click save. So this is going to create a value for the 7th of April as well. Now we have values in here for 3 different dates. We've now seen the core components of DynamoDB and how all of them fit together. Now this is schemaless, which means you can have any different type of properties on each item. DynamoDB does not mandate all items should have the same properties, but on a bare minimum, it should have the primary key properties. Now, when you get started, it might be a bit tricky to start choosing partition keys and sort keys. Now, DynamoDB has a well-documented page, which I'll put in the link below, which walks you through different considerations that you can make when choosing a partition key. So you can go through this and understand more about this in detail. But as you can see, in each AWS account for a region, it can have multiple number of tables. Each table has a partition key based on which the values are partitioned and stored physically on different partition ranges. Now each of these table items, which is a row inside here, has a primary key, which can be a composite of partition and sort key, and it has other properties. Now that we have a good understanding of DynamoDB and the core components, let's switch back to our application and make it start using this particular DynamoDB table that we have added. So switching back to Rider, let's modify this weather forecast controller to start using the DynamoDB. To do that, we will need to add a NuGet package. So let's go over to the project, right click and say manage NuGet packages. Let's search for DynamoDB and this pops up the AWS SDK.DynamoDB v2 package. This is the one that we need. So let's install that into this current project and click install. The package is installed successfully. So let's close these and start using it inside our code. The NuGet package which we just added provides an iDynamoDB context. So we can inject that inside here into this constructor. Now we could directly create the context inside the controller, but it's generally preferable to inject in these dependencies. So let's create the DynamoDB context, create a backing property for this. Let's save this onto a class variable so we can create a read-only field which is _DynamoDB context, and that's getting saved inside the constructor. Now to start using this, let's modify this get method. Let's move this existing dummy data method into a different method. I will use this in a short while. So let's say generate dummy weather forecast and click next. So this refactors out that existing method. I'll use that later. So let's remove this and start using the context inside here. So we have the DynamoDB context. We can use the query async method to start querying the DynamoDB table. So specifying that, it prompts us to specify the type. So in this case, this is going to be weather forecast. This has multiple variations, one which takes just a hash key value and one which takes a hash key value and an operator. So let's specify the hash key value for now. Now the hash key value is the same as the partition key, which is used to create the hash, hence the hash key value. The sort key that we created is also referred to as the range key. This is because it specifies the range of values within the partition. Now these two names are often interchangeably used, so don't get confused. So partition is hash because it creates the hash key, and the sort is the range because it provides the range key. So let's specify the city name in this particular case because that's what our partition is. Now by default, it has the value Brisbane. So let's then call the get remaining async, which gets all the items inside this particular query. So let's make that call. Now since this is an async call, let's add in the await and also specify the async and a task return type. So this is returning now a task of IEnumerable of weather forecast. Let's also make sure to return this data from the DynamoDB once it fetches back. With that set up, this controller is now using the DynamoDB context to query a Dynamo database. Now we'll need to set up the DynamoDB context so that the application can resolve it when it asks for this controller. To do that, let's head over to the startup.cs, which is where we specify the dependency injection. Now, if you're new to dependency injection in ASP.NET, I have an entire video that walks through it. It will be linked here or in the description below. Now coming to the startup class, under the configure services method, this is where we need to specify the dependency injection services. So let's collab these and start registering the services. So let's specify services and add in the DynamoDB context. Now this is a thread safe class, so we can add it as a singleton instance. So let's specify singleton and create the DynamoDB context. Now this is implemented by the class DynamoDB context from the same NuGet package. So let's register that. If we navigate to the DynamoDB context class using F12, you can see that it has a constructor which takes in a DynamoDB, which is a DynamoDB client instance. Now this is not yet registered, so let's go back and register that. So coming back to startup, let's start creating a DynamoDB client. To register the DynamoDB client, let's create a new property. So let's say var client is equal to new Amazon DynamoDB client, which is the class that implements that client. Now this has lots of different constructor overloads. I'll use the one that takes in the credentials and the client config. So let's pass in credentials, which we will just create now, and also the config. Now let's create these two variables. So let's go up again and specify credentials. Now for demo purposes, I'll hardcode the credentials inside the code. But in a real application, you would want to keep this out of your code, so you can use it in a configuration file and also specify a secrets manager that can be used to keep secrets out of source control. If you're new to it, check out the video linked here. Also, if this application is deployed inside the AWS infrastructure itself, you can configure the IAM so that it has access appropriately. I will be covering those in a different video. But for now, to keep things simple, let's hardcode the credentials right here. So let's create a new basic AWS credentials, which takes in an access ID and a secret. I'll create those in a moment. So let's leave that with blank strings. Let's also specify the config, which is going to be a new Amazon DynamoDB config, which takes in lots of different values. In this particular case, I just want to specify the region endpoint. And in my case, I use the Southeast 2, which was the Sydney region. So I can specify the region endpoint and say AP Southeast 2. Now, depending on the region of your application, you can choose whichever region that you created it in. Note these values can also be in the configuration so that it can be different for different application instances. Let's make sure to end the semicolon, and now this code compiles correctly. Now that we have the client created, let's register it into the services collection. So let's say add singleton again and specify the interface, which is Amazon DynamoDB, and pass in this created instance. So we can specify client. To specify the basic AWS credentials, let's navigate to the AWS console, go to IAM dashboard. You can search that from here, navigate to it. Under users, you can create a new user. I have one already created, which is called DynamoDB, but you can do a new one from here. Now under this, you can specify the required permissions for this user. In this case, I have granted it Amazon DynamoDB full access. You can restrict the permissions based on your application's requirement. Once that's set, you can also go to the security credentials to create a new access key. So this will give you the access key ID and also a secret associated with it. So if you want to create a new one, you can click create access key. Now that's going to create one automatically. So let's copy and paste this access key that I have created into our code. So let's specify the key ID and also the secret value. Now this is now able to talk to the Amazon DynamoDB instance. With all that set up, let's run this application to make sure this is working as expected. So let's make sure to put a breakpoint inside the weather forecast controller. It launches the Swagger UI as before. So let's navigate to the weather forecast, click try it out and select execute. This by default has Brisbane city name. So let's select that. Now this brings in the city name as Brisbane, and this is making a call to the DynamoDB context. Let's resume the execution using F5, and this returns back the data from the DynamoDB database. So you can see all the details that we had added, which is 3 items for this particular city. So the same 3 items exist inside the DynamoDB console as well, just like that we added. Now we have successfully retrieved the data from a DynamoDB database from this API. Now currently, this call is returning all the values under the same partition. Now if you have the weather data for a long time, then this method is going to return all of that. To filter the values, let's use an overloaded method of the query async. So let's pass in a query operator, which takes in different values like between, equal, greater than, etc. So let's specify the between operator and pass in a list of values. Now this requires an enumerable of values. Now based on the operator that you have selected, you might have to pass in one or more. Now since between needs a from and a to date, let's specify two values. So let's create a new object array and pass in the date. So let's specify datetime.utc now. Let's just specify the date and also the next value as datetime.utc now.date and add 2 days to it. So let's specify the add days and specify 2. Now this is going to get the values between these two ranges. So let's run this application again and make sure this is working as expected. Let's click the execute button and it makes a successful call and returns back the data as expected. Now there is only one value for that date range, because of which it only returns one value. Now based on your application needs, you can use different operators inside this query and specify the attributes appropriately. Now that we have the get method working fine, let's start adding items to the DynamoDB. So let's create a post method, specify public async and specify just task because we don't want to return any values, and give this a name post. Let's also take in the city name as before. So here let's create some dummy data. So let's say data is equal to generate dummy weather forecast, which we extracted before, and pass in the city name from there. Now this is going to create us a list of data based on this dummy data generation logic. So we can iterate through each of these items inside here. So let's specify the data property that we just created and use this as item. To save these items into the DynamoDB, we can use the DynamoDB context and call the save async method. Now since the type is automatically deducible, we can simply pass in the item to this method. Let's also make sure to add in the await call. So here we are generating some dummy data and saving this one by one to DynamoDB. So let's put a breakpoint here and run this application to make sure this is working as expected. The Swagger UI is shown. It shows the new method, the one that we just added. So let's click try it out and specify a new city name. So let's specify Sydney. Now clicking execute, it's going to hit the breakpoint. It's generating this data for us automatically and looping through them and calling the await DynamoDB context. Let's resume the execution and navigate back to the DynamoDB console. If we refresh this, we can see all the values that we just added in here. Now this has 5 values because that was generating 5 values. One thing to note here is the datetime values. Even though I specified my current local time, the AWS SDK has automatically converted it into UTC datetime. Now this is happening by default because of the SDK converter that is available inside here, which is the datetime converter 1. So if you see, when it tries to convert it, it automatically converts it into universal time. So if you want to override this behavior, you can add in a custom converter for this type, which I might cover in a later video. So if we come back to the DynamoDB console, we can see these values have the time component as well associated. That's because I had used just the datetime.now to create the values. So if you don't want that to happen, you can remove it by specifying the date property as well. Now, but this is still going to convert it into UTC time. So let's run this again. Let's choose a different city for now. So let's give in London and say execute. So this is again going to generate the data, but this time without the time component. So if we switch back to the DynamoDB console and refresh it, we can see all the values for London that's created. However, note, it has automatically converted into UTC time, which is 1400. Because the time component was 00, it automatically assumed it was local date time and it converted it. So be aware of this behavior and use custom converters if you want to. Now, if I run the same post call again, it's going to create similar data but with different values. So if I run this again, let's say, it's going to again call this. It's going to call the generate dummy data, but it's going to be for the same date range. Now, if I run that and come back to DynamoDB console, these values are going to change. So if you keep a note for London, this was 54. If I refresh, now this has become 42 and 35. Now this is because the save item is automatically updating or inserting the item inside here. If it finds an exact match with the partition key and the sort key, it updates that item. If it does not exist, then it creates a new item. Now, if we want to explicitly update an item, let's say var specific item, we can use the load method. So specifying the await on DynamoDB context, use the load async method, and we can load a weather forecast item. I can specify the partition key, which is the city. Let's also specify the date time for which this needs to be loaded. So let's specify datetime.now.just the date part, and let's add 1 day. So this is going to take tomorrow's date, which is the 5th of April. Now, once we have the specific item that we have loaded, we can update the properties independently. So let's say summary and give it a value of test. Once updated, we'll need to make sure to save this item back. So let's call the DynamoDB context and the save async and pass in the specific item again. So let's run this and make sure this is working now. Note, I have commented this code so that this does not automatically create the data anymore. Navigating back to Swagger, let's click the execute. So it calls for London. It picks up the specific item. So it uses the datetime.add and it takes the next day's item. So we have the value populated back up and we have the summary getting overridden. Now let's save this back and navigate back to the console to see if that's working as expected. If we refresh this, we can see the value test being updated for tomorrow's weather summary. Similarly, to delete an item, let's add in an HTTP delete endpoint. So let's specify public async and give in task and say delete. Now this is also going to take the city name. So let's specify the city. We can either load a specific item and delete it or also delete it by the range key. To delete, we can pass in an item explicitly as before. So let's add in the specific item and then call the DynamoDB context.delete async and pass that specific item to this method. So let's make sure to await as well. Alternatively, you can also pass just the city name and the date if you have that with you. So let's run this to make sure this is working as expected. We have the new delete endpoint. So let's call this for the city London and see if that is getting deleted. So this returns a success. So let's go back to the console and this 0405 is going to go away. So let's do the refresh and the one with the test is now no longer there. So we have successfully deleted it. Now, if you have the explicit partition key and the range key, you can also use that to delete it directly without having to load the item initially. The DynamoDB SDK provides 3 levels of APIs. So there is a low-level interface, a document interface, and a high-level interface. Now, these are part of different namespaces inside the same NuGet package. What we used is part of the high-level interface. This falls inside the Amazon DynamoDB.data model namespace. So if we navigate back to the code, we can see under the usings, this is using the Amazon DynamoDB.data model. This also uses the document model just for this query operator. So if we remove this, we can see this is the only one that throws an error. Everything else works as expected. Now, some functionality is not available as part of the high-level interface. Like if you want to create a table dynamically, you cannot do that using the high-level interface. I'll walk you through that in a separate video where we set up testing for this application. I hope this helps you to understand and get started with DynamoDB and how to interact this from a .NET application. To keep things simple, I manually created the table using the console. In an upcoming video, I will show you how to automate this so that you can create these tables dynamically onto any environment that you're deploying this application to. We will also see how to set up local environment using Docker and run DynamoDB inside that. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please make sure to hit subscribe. It really helps me to grow this YouTube channel. Thank you and see you soon.